Hi, my name is Emma Söderberg, and I'm an associate senior lecturer at the Department of Computer Science at Lund University. In this talk, I'll talk about whether we can make source code analysis more useful together and whether we want to. So, source code analysis. Well, many developers have seen source code analysis in one way or another. So developers use many different tools in their day-to-day work. So source code editors, many times code review tools and continuous integration tools. And in the setup of tools, you many times see source code analysis popping up. So for instance, you may see warnings in your editor, things like unknown variable here, for instance, warnings from the compiler that does source code analysis. Or you may have in sort of some connection between your code review tool and the continuous integration system, warning you of some warnings that appeared on the change that is under review. So over in the continuous integration system, many analyzers may run and provide warnings of somewhere in some log somewhere, and you can get notified and then can go and have a look. And these kinds of results from analyzers, they assist developers. They help them see things that they maybe forgot to look at. They automate some of the things that is needed during development. So that's good. So there's a lot of benefit in using source code analysis. However, there's a number of usability issues that's been shown in several studies. So issues around poor integration, where developers may be excited about a new tool at some point, but over time they stop using it because they have to go somewhere else to use it or something like that. Or tools that are just where the results are really hard to understand, so they're incomprehensible. Making it really hard to understand whether you need to do something or not. Or false positives, where tools are saying something that isn't true. So for instance, if you have a notification in code review that something is happening in your continuous integration system, you go over to look for the logs and you see warning, warning, warnings, you see something you don't understand, and then warnings. In the middle of that, if you think about false positives, it's like the analyzer is saying wolf, wolf, maybe there's an actual warning, something you don't understand, and then wolf again. And that decreases trust. And it's like the story, the boy who cried wolf. So that's a big problem for adoption of program analysis. So many times people start ignoring these tools if they behave like that. So what's going on? So we have plenty of these analyzers that could be really beneficial for developers. But for some reason, there are all these usability issues. And one thing that you could imagine that's going on is that analyzers are being developed over here, and then they're kind of thrown off the wall to developers, and whether they make it or not, whether they're useful or not, it's unknown. So this feedback doesn't typically get back to the people maintaining the tool. So one way to tackle this is to introduce more feedback. So here is one system, which I'll explain a little bit more in detail. It's based on, the illustration is based on the tricoder system, which is a system that's running at Google, which is focused on integrating program analysis results into the developer workflow and gathering feedback on where they are presented. So it's tackling several of these issues that I just mentioned. So for instance, effort of using program analysis results is tackled by integrating results into the code review environment. So you get so-called robot comments next to human comments. And on top of that, there's a little not useful button on these results, which allows developers to say, well, in the context where they see the robot comment, they can say, well, this is not useful to me for one reason or another. And by clicking that button, which is something that we refer to as a probe, feedback is gathered over here in this system, which is an illustration of the tricoder system, which is some of you would call a meta-analyzer system. So it's gathering feedback, and this gets to some admin on this side over here, someone who can take that feedback and realize that there's an issue with this newly released analyzer. No one understands the message, and we need to do something about that. So you can go and maybe fix the analyzer or turn it off, depending on what your options are. So you can tackle incomprehensible messages. You can also react to false positives, put limits on how noisy an analyzer is allowed to be. And then if it's too noisy, you turn it off. So you can have rules around these things, which is done in the tricoder system. So this has been quite useful at Google. So I've gone out to developers outside of Google and I've talked about this approach. And part of the feedback that I got initially when doing this is that developers would be hesitant. So they would be sort of saying, we're not Google, we don't have that sort of, we're not that size, we don't have the resources, not sure this would work here. So that got us interested to the point where we said, okay, let's go and see what we can do about this. Let's go and study what we can do at one of these companies. So we ran a case study at a company where we studied their developer tool stack, investigated the existing systems. Tricoder has some follow-up systems called Tricium and ShipShape, partly in open source, but we ended up having to kind of implement a new one to really work with an open tool stack that we were using here. So it's a system called Mean that we designed in this case study. And then we deployed it over 8 weeks for gradually up to 400 or so developers and gathered data to see how well we could get this feedback loop up and running. And in short, the system produced a lot of sort of results. You can see this plot over here, which I won't explain in detail, but results are produced over the week, and you see there is a weekend every now and then. Fair small amount of those results are actually we could use in how we estimated this, and this is not full precision on this, and we don't have the numbers for Tricoder, but that is interesting to us, so we will probably want to explore this a little bit further. We did see that a fair number of users actually engaged with the system. They were using the feedback mechanism, clicking the button rather than finding people to talk to, suggesting that they kind of got into that workflow. We got a higher user engagement compared to Tricoder, as far as we know this from numbers in the paper at least. And in the end, the administrators of the system, when we were running this case study, could actually get this feedback, tune the system, and sort of work with this feedback loop to improve it. So it was we see it as a positive result. So this is an early deployment of analyzers, so things are a bit more noisy, but we could definitely see how we could react to this using this feedback loop. So, but still, it's a company with up to, in this case, 400 developers, compared to maybe 30,000 or so at the time when the Tricoder paper was written. So that size is still a factor. So more developers, more data, more opportunities to sort of tune the system. So the question is then, if we have many small companies or companies this size, can we kind of come together and go beyond organizational boundaries? Can we build a community around this? So if we have one company here, for instance, we already share analyzers in open source. So open source analyzers are common. So can we take it to the next step? Like, can we share data about how we use these analyzers to help each other out, to tune this, to make them more useful together? So that's where we would like your input. Can we make source code analysis more useful together using an approach like this? Do you want to? And we'd love to get your input on this. So please answer our survey. You can find the link here or in the chat. And thank you for listening.